Hi guys, welcome to MCQs. Today we are going through Physics IAL Unit 1 Mechanics and Materials. This paper was supposed to be set in May 2020, but due to coronavirus it was set in October-November. So without further ado, let's get started. Question 1 is, which of the following units is only used with vector quantities? As always, mark out the incorrect ones. So joules is used for work done, so this can't be an answer, as work done is a scalar quantity. Meters is for distance and it's a scalar quantity, it's not the answer. W is for watts and that's for power, and that's not either a vector quantity, so the only option we are left with is C, and that's Newton, and that's a vector quantity. Second question is, a box was placed at the top of a ramp and released. The free body force diagram for the box as it moved down the ramp at a constant velocity is shown. Which two forces acting on the box have, according to Newton's third law, corresponding forces acting on the ramp? Okay, first let me draw the box and the ramps. So the box is placed like this. As you can see, the normal force goes there, the weight goes down, and all these forces mentioned here, and they ask us which two forces act specifically on the ramp. So within the ramp, first force that acts around is the frictional force, and the second force that keeps it all along the ramp is the normal reaction force. So pretty easy, that's B, F and R. Always whenever they ask us on the ramp, we have to give these answers. Third question is, the diagram shows a roller coaster. A roller coaster car stops momentarily at P before descending towards Q. And the question is, which of the following expressions could be used to determine the velocity of the roller coaster car at Q? By asking us the velocity and giving us the distance or the height, the only thing that comes to the mind is kinetic energy equal to potential energy. There you go, I've set them together, and we have to find the velocity. We don't know the mass, so the masses here will cancel as they are on the opposite side, and I'll take 2 there on the top, and I will get an equation of V equal to root of 2 into G into H. Now coming to the height, from P to Q we have a height difference of 75 minus 30, which is of 45. So they specifically ask us the expression used of the roller coaster at Q, so we have to give it specifically at Q. So 75G minus 30G won't be the good contender, because it's having a difference between two of the speeds, so that won't be our answer. Neither with these values, we're doubling the values here, and we only left with C and D. So when I multiply 2 into 45, I get 90, and the only option we are left with is D, so our answer is D. Fourth question is, a car travels north with a velocity of plus 50 meter per second, that's positive. While still traveling north, the car slows to a velocity of positive 20 meter per second. Which of the following is a change of velocity of the car? Here I've set terms in bearing, and whenever something slows down, it doesn't add up. So I'll cancel the positive terms, nothing is being added up. So our change of velocity is going from 50 to 20 meter per second, and that's a decrease of 30, not 70. So B is clearly our answer. Fifth question is, two forces P and Q act on an object as shown. Which of the following is correctly drawn scaled vector diagram for the resultant R forces P and Q? Okay, fine, I'll show you all these options. I'll just scroll up again just to see our initial vectors. Okay, that's P and Q that side, and they want us to have a resultant R in which direction. Okay, if I talk about A, this clearly doesn't make even sense, that like R is traveling on the opposite side even when they made that parallelogram, so A is not our option. Same with B, R is traveling in the opposite side, so B can't be the option. For option C, we can't have tails on the same side of the head, so C is not our option, and we are left with D, so our answer is D. As you can see clearly that P is on the head or tail, R is moving on the correct direction. A lamp with an efficiency of 0.68 usually transfers 120 joule of energy. Which of the following can be used to determine E, the energy supplied to the lamp? So quick and easy trick. Energies are not being multiplied here, so just cancel out the multiplication sign because they are being divided by 100%. So we usually take the decimal or the percentage at 68% efficiency. We know that 0.68 is already being converted to decimal form and it's not being multiplied with 100. So C and the D is our final answer. It clearly shows to determine the E, the energy supplied to the lamp only. Question 7. A student used a falling sphere to determine the acceleration of free fall g. The sphere was released from rest. So if it's rest, the initial speed is 0 meter per second. Just write it down, write every bit of information you know from the question below. Which two quantities would require the fewest measurements to be taken in order to determine g? If you take one of the Suvet equations to find g, we can clearly see this equation will be required to find g or the a value, and they say that we should require the fewest measurements to be taken in order. There is no t, so we just cancel out these options. And B and D is left. Final velocity, obviously we have to find the final velocity. With the speed it drops down, the sphere drops it, and B is a strong condenser, so B will our final answer. 8th question is, a stress is applied across the ends of wire of cross-sectional area A. Work W is done to extend the wire by delta X. Which of the following could be used to determine W or work done? I will be drawing a graph to depict work done in terms of stress against strain. There is a graph, and work done is area under this graph of stress against strain. Talking about strain will be the extension or X, which is here, into cross-sectional area, and that will give us the option C, which clearly tells us that half into stress into A into X, not X square. Extension is not squared, so those are not our options, and that's our final answer. Questions 9 and 10 refer to the information below. The velocity time graph for motion of a ball is shown. That's the graph for velocity time. Which of the following correctly describes the motion of the ball? Okay, fine. The ball has been dropped. Okay, I'll look forward for the A. The ball is dropped and rebounds its original position. That's not true. The ball is dropped and rebounds to a lower position. Okay, fine. I'll just keep it, and then I'll go through other options. The ball is thrown upwards and is caught at its original position. Nope. If it's thrown upwards, it's opposite to what it's been drawn. It's being thrown downwards or been released. The ball is thrown upwards and caught at higher position. Nope. So the only option we are left with is B. Why B? Because when the ball is dropped, basically it rebounds with less energy, because the energy is being dissipated or like lost as sound or heat energy. So B is our final answer. 10th question is, which of the following graphs of displacement against time could represent the motion of the ball? So clearing out the wrong options, displacement time graph, B and D are clearly not the options because they show no change in velocity. There is no sign of change in velocity within these graphs. So we are left with A and C. As I mentioned earlier, the ball basically bounces and rebounds with lower energy, and the A part shows energy which is still the same when it drops off. So A can't be the answer, and we can clearly see that C is the right answer. And that's all MCQs done. I hope you like the video. Do subscribe and stay tuned for more videos from these series.